This is lesson 9, metals and their extraction. We're going to look at electrolysis, oxidation and reduction reactions, and we're looking at pages 54 to 59. So electrolysis is splitting up a compound. In your book, it asks you to add arrows to show the directions that these ions are moving. If you see Br minus, minuses will be attracted to the positive electrode, so bromide will go to the anode, lead will go to the cathode. So opposite charges attract. What I'd like you to do is to watch this video on the electrolysis of lead bromide, and then you can complete the rest of the slides on this PowerPoint and they match your book. So you'll complete the pages then in your book. So you watch this video about the electrolysis of lead bromide and then you answer the rest of the questions. Now for the next 2 pages, higher tier, you're the only ones who need to look at the half equations. Everybody answers the bottom bits here. And you can work out what ions are being attracted to the cathode and the anode. But higher tier, you're the only ones that need to worry about the half equations. Now oil rig means oxidation is loss of electrons and reduction is gain of electrons. So if electrons are lost, we call that process oxidation, and if electrons are gained, we call that process reduction. The next 2 slides are for higher tier only, but we will come back together at the end of the PowerPoint because everyone will do the last slide or so. So after reading them, try to complete the half equations on page 57 and 58. Also, there's a slide of practice half questions at the end of this PowerPoint that I want you to write out and complete in your booklet or on paper and glue in. You can write these half equations out at the top of page 57, 58 or 59, or just get an A4 sheet of paper and do it on there and glue it into your book. Okay, so just find some room. And these are just for the higher tier. Now half equations show us where electrons are being gained and where electrons are being lost. So for example, if we look at sodium, sodium is a metal ion, so it's positively charged, and that would attract to the negative electrode. We know that, as opposites attract. Now because it's got a plus there, it hasn't got a number by it, that means it's lost 1 electron. So to become a sodium atom again, it needs to gain 1 electron. So the half equation would be written like this. Na plus needs 1 electron, which is negatively charged, to become a sodium atom. And that would be your half equation. Because the sodium ion is gaining electrons, from the previous screen we know what oil rig stands for. Oil rig. It is a reduction reaction because it's gaining electrons. And this would occur, well, if you think about the sodium ion, it's positively charged, it would be attracted to the negative electrode, which is also known as the cathode. Another example, the chloride ion, that's negatively charged, so it would be attracted to the positive electrode. When it gets there, it loses an electron to make a chlorine atom. But chlorine only exists as Cl2, so the half equation is this. So if you ignore the 2's for a minute, Cl minus needs to lose 1 electron to become Cl. But chlorine doesn't exist on its own, it only exists as Cl2. So you have to have 2 Cl minuses to start, they lose 2 electrons, and then you end up with Cl2. So we're just balancing it. However, we do not write it like this because there are too many minuses. You can see there's lots of minuses there, so we write it like this. So you take that minus 2 electrons over to the other side, pretend it's an equal sign, so it changes its charge, and you've got 2 Cl minus, ends up as Cl2 plus 2 electrons. So it's exactly the same, it's just we've moved it across the arrow. Now because the ions are losing electrons, it is an oxidation reaction, and it occurs at the positive electrode because the chloride ions are being attracted to the positive electrode. Now everyone can complete this, and the words are given to you in the book. And this screen is purely for higher tier. So copy these out, complete the half equations, balance them, and state whether they are oxidation or reduction equations, and at which electrode would they occur. So try those 6 examples, please. Just higher tier for that. Everyone for this one.